morning, good afternoon, good night. I hope that you're doing good. This will be a video about the Pascal's triangle, about the binomial theorem. We're going to be solving is a selected set of exercises from the review packet. Uh, the first thing that we need to establish is how um, we have to draw the Pascal's triangle. So here, I am doing something that we most of the times we don't do, that it's grading the row 0. Because I have seen that most of you start drawing the triangle with row 0. But like, if my row only has a 1, that is row 0. That is not the level 1. This could be a mistake that will drive you to being very unsuccessful. So be very careful. Row 0 only has a 1, or you can start drawing your triangle from row 1 that has like two ones. No? It's great, but like the amount of elements that you have in your row is one more than the number of the elements. So in row 0, I have one element. In row 1, I have two elements. So how do you draw the Pascal's triangle? You draw the Pascal's triangle by following these two rules. The first rule is I always start and end with a 1, and I add the two numbers above to get the next one. So for example, if I want to draw row 2, then I start with a 1, I add the two numbers above to get the next one, and this one I don't have any number above, so I end with a 1. So start and end with a 1 and add the two numbers above. This row now has 3 elements. To get row 3, I start with a 1, I add the two numbers above. 1 plus 2 is 3, 2 plus 1 is 3, and I have nothing above. Well, I have only one number above, so like I need to end, and I end up with a 1. In row 4, the same thing. I start with a 1, I add the two numbers above. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, I need to end, and I end up with a 1. Start and end with a 1, so I start with a 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, 1, I need to finish, so I end up with a 1. And the last row that we're going to draw is 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, I need to end, so I end up with a 1. There are so many beautiful patterns here in the Pascal's triangle. So like, for example, 1, we have already said it, is I have one element more than the number of the row. So if you look at the midterm, it is symmetric. No, the row is symmetric. So for example, I have 1, 2, 1, or for example, if you go to this one, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So it is symmetric. There are a lot of very interesting patterns in the Pascal's triangle. Let us start using it in one of its first and most important applications, that is to expand terms. So in the first question of the review packet, I have this. I have y minus 3x to the power of 5. And the other day I was speaking with a student and she told me like, oh, Mr. Cachoa, why, this is basic algebra. I just have to do y minus 3x times y minus 3x times y minus 3x times y minus 3x times y minus 3x. And she was right. But it's like a lot of distributions. No, it's multiplying and multiplying and multiplying. And you don't need to do that amount of multiplications to expand this this expression. You can use the Pascal's triangle. So the exponent always tells me the row number. So here I am in row number 5. So the exponent is telling me go to row number 5. If I go to the row number 5 in the Pascal's triangle, I can see that the numbers in that row are 1, 5, 10, 10, 5, 1. Okay, so that is the first thing that I'm going to do. I'm going to write down, I'm going to write down 1 plus 5 plus 10 plus 10 plus 5 plus 1. So I write down the numbers that appears in the corresponding row of the Pascal's triangle. Then, and here is the confusing part, so be careful. My binomial has two terms. The first one that I'm going to draw in blue, y, and the second one, minus 3x, that I'm going to draw in green. So the first term, I'm going to write it in decreasing powers, starting from 5. So I'm going to start putting a y5, then a y4, then a y3, a y2, a y, and no y's. So the first term, I write it in decreasing powers. 5, 4, 3, 2, 1, y to the power of 0, so I don't need to write it. And the second term goes in an increasing amount of, in an increasing uh, in increasing powers, no? So like if the first one go in decreasing powers, the second one goes in increasing powers. A way that I say it in class, and that I have always said it, is to go like in a reverse. So if here I start with y5, in the last term, I'm going to start with minus 3x to the 5, minus 3x to the 5, minus 3x to the 4, minus 3x to the 3, minus 3x to the 2, minus 3x, no minus 3x. Take a moment, pause the video, look at it, and look at the pattern. The blue one is decreasing, the powers are decreasing, and the green one is increasing. So like, for example, here I have no green one green, two greens, three greens, four greens, five greens. Okay, now we're gonna do this. Okay, take a moment, pause the video, breathe. So this is, I want you to understand how the pattern is working. Okay, so now that you have understood how the pattern works, we're going to simplify each term. So each term has a little operation, and we're going to make it. For example, here, it's the easiest operation. I didn't even write it, sorry. It's 1 times y to the power of 5. 1 times y to the power of 5, that is just y to the power of 5. So that was like very easy. But the second one, the second term, also has an operation. This one is a little bit more complex, no? It's 5 times y to the 4 times minus 3x. Y times 5 times y to the 4 times minus 3x. I am talking about this term. So how do I multiply this? This is 5 times minus 3 minus 15 x. I just have 1x, and I have 4 y's. This is a y, sorry. Then the next term, if you're saying that this is minus 30 xy cubed, that is a mistake. A mistake-o, be careful. Because here I have negative 3x squared. And what is negative 3x squared? Negative 3 squared, o sea, negative 3 times negative 3 is 9. Positive 9. So this is 10 times y cubed times 9 squared. Oof, be careful here. So I am turning this negative 3x squared into a 9x squared, because the little number 2 goes to the negative 3. So negative 3 squared is 9, and x squared is x squared. Then I can do, as in the previous term, 10 times 9, 90. It's a positive 90 x squared y cubed. So the second term is negative, but the third term is positive. Be careful with that one. For the next term, we are going to do 10 y squared times minus 3x cubed. So again, we first need to do the minus 3x cubed. What is minus 3x cubed? Well, minus 3 cubed, that is minus 3 times minus 3, o sea, 9 times minus 3, negative 27. So this is going to be 10y squared, negative 3 cubed, o sea, negative 27, x cubed. I now can multiply numbers by numbers, so that is 10 minus 27, and that is minus 270 x cubed y squared. The next term, I now to do a higher power. No, so this is negative 3 to the fourth power. What is negative 3 to the fourth power? Negative 3 times negative 3, 9, times negative 3, negative 27, times negative 3, so it's going to be positive, positive 81, because I am doing negative 3 times negative 3 times negative 3 times negative 3. So this turns into 5y 81 x fourth. And if I multiply 5 times 81, that is 405 x fourth y. And the last term, I just need to do negative 3 to the power of 5 x fifth, and negative 3 to the power of 5 x fifth is negative 243 x fifth. So I want you to notice that each term is made out of three things: the black number that comes from the Pascal's triangle, the blue number that comes from the first term in decreasing powers, the green number that comes from the second term in increasing powers, and this each one of those you simplify them. Your final answer. What is my final answer, Mr. Cachoa? My final answer is just putting all the terms together. No, so it's like the first term is just y5 minus 15 xy fourth. It is this term. The second term, the third term, 90x squared y cubed minus 270 x cubed y squared, 405 x fourth y, negative 243 x fifth. No, so that is how you solve this problem. And let us do another one. We're gonna do like 3 of this, I believe. So now we're doing number 6. In number 6, again, I am expanding. So I need to look at the row in the Pascal's triangle. So the exponent, the power, is telling me what row to the Pascal's triangle I need to go. So I need to go to row number 4. So the first thing that I do is write the numbers of the Pascal's triangle. I know, like, I'm sorry, like here I should have done a little bit of more magic. So the first thing that I do is write the black numbers, the numbers of the Pascal's triangle: 1, 4, 6, 4, 1. Then the first term, it goes in decreasing powers. No, so the first term, the blue one, is y4, y3, y squared, y, no y's. And the green term go into increasing powers. So in backwards, it will be 4x4, 4x3, 4x2, 4x, no 4x. Look at the pattern. So each term is composed of a number from the Pascal's triangle, the blue term in decreasing powers, and the green term in increasing powers. Okay, dokie. Now we're going to simplify each term. Here, I did simplify the first term that it was like kind of dumb, 1y fourth. Then 4 times y cubed times 4x. So 4 times y cubed times 4x, that is just like, this one has no exponent, so it's the same. 4 times 4, 16, x, y cubed. I am simplifying this term. No, 4 times 4, 16, x times y cubed, xy cubed. In the next term, this one, 6y squared, 4x squared. So here I do have an exponent, so I do need to simplify first this parenthesis. So this parenthesis, that is 4x squared, so that is 16x squared. Okay, now that I have simplified the parentheses and there are no more exponents above the parenthesis, above the parentheses, now I can multiply 6 times 16, 96, x squared, y squared. Then the fourth term, that is 4 times y times 4x cubed, so that is 4y times 4x cubed. And what is 4x cubed? 4x cubed is 4 times 4 times 4, o sea, 64x cubed. And then I multiply 4 times 64, and that is 256 x cubed y. And then I simplify the last term, which is just doing 4 to the power of 4, which is 256. Now that I have simplified all of the terms, my final answer is just writing them down together, no? So y fourth, 16x y cubed, 96x squared y squared, 256x cubed y, 256x fourth, and that is how you do the first, how you do the final answer, no? Okay, so I hope that with these two examples, you are able to do like the first part of the review packet. This is a very important skill. So look at the pattern. Each term is made out of 3 parts, and then simplify each of the parts. Okay, I'm gonna give you a way of finding the general term using a certain formula. I strongly believe that this is going to be very helpful and useful. Eh, Now, if you ask me, Mr. Kachoa, can I survive the exam without using the general term formula? I'm going to say yes, you can survive without the formula. But you want your hundo, if you want to ace every single question, then I would suggest you to understand and apply the formula. Because most of the problems can be solved using only the Pascal's triangle. There are some problems that are way easier to solve using the general term formula. So let me guide you through it. So the general term formula, a plus b to the power of n, the general formula of a plus b to the power of n, so like n is going to be the exponent and r is going to be what term I am looking for minus 1. So this is the general term formula. We're going to apply it. We're going to use it very heavily in this video. And we're going to use this general term formula to find like particular terms in my expressions. So like when do I use it? So I use it when I am asking you find the fifth term of the expansion a plus b to the n. So for example, my question could be like in this here find the second term, and a way to solve it would be like expanding, and this is the second term. So like you don't need to use the formula for this. Do you notice? But like using the formula will make this journey way shorter. Um, so this is the formula, and maybe right now you're asking, what is NCR? NCR stands for N chooses R. We have done it before. That is the factorial formula. No, N chooses R. It's like N over R times N minus R. You know, like the numbers that are screaming. So we're going to be using this formula. I'm going to do many examples of how to use this formula in the following, in the whole video. In class, I did it with the Pascal's triangle. I want to do it with the formula so that you can also use it. No, it's a great tool. I know you. You're right now saying like, I don't want to use the formula. Please trust me. Use it. Okay, so for example, in question 9, I am asking, what is the fourth term in 2x minus 1 to the power of 5? So look, I am asking for the fourth term, and this is my expansion. So I need 4 things to apply the formula. No, I need to know what is A, what is B, what is N, and what is R. N is the exponent. No, N is the exponent. R would be the number of term minus 1, so that would be 4 minus 1. And what is A and what is B? A is my first term, 2x, and B is my second term, negative 1. So again, I need 4 things to apply the formula. A, B, so A is my first term, the first part inside of the parenthesis, B is the second part inside of the parenthesis, N is the exponent, and R is the number of term that I'm looking for, minus 1. In this case, the formula would be this, would be 5 chooses 3, 2x to the 2x squared minus 1 cubed, no? Because if you look at the formula, this exponent is n minus r, 5 minus 3 is 2, and r is 3. Oh my god, I know, maybe you're confused right now. I'm gonna do several of this. If you want me, I can repeat it. I'm gonna show you the formula again. The formula is n choose r, a n minus r, b to the power of r. If you have a pencil, write it down, meditate on it. Uh, so in this case is 5, choose 3, 2x squared minus 1 cubed, no? The squared is because it's 5 minus r, and this one is r. Okay, so 5 choose 3 is 5 factorial over 3 factorial times 5 minus 3 factorial. What is 2x squared? 2x squared is 2 squared, o sea, 4, and x squared, like that, no? And minus 1 cubed is minus 1 times minus 1 times minus 1, so minus 1. This number, grab your calculator, find it, that is 10. So this is 10 times 4x squared times minus 1, and now you multiply, and ka-choom, pow, that is your final answer. So the fourth term is minus 40x squared. So you don't have to do the whole expansion to find the fourth term. You can just apply the general term formula. Okay, let us do it again. For question 11, I want to find the fifth term of x plus y to the power of 6. So the first part is my a, the second part is my b, n is my exponent, and r is the number of term minus 1. So in this case, my formula would be 6 choose 4, n choose r, a to the power of n minus r, o sea, 6 minus 4, 2, times b to the power of r, o sea, y to the power of 4. Now, I find 6 choose r, so that is 6 over 4 times 6 minus 4 times x squared times y4. If you plug it into your calculator, that is just 15, so it is 15x squared y4. Putting this into your calculator is a skill. You need to know how to do this, no? Great. Oof. So I'm gonna still use the general the general term formula to solve, for example, this problem. So look at this problem. This problem is telling you that I want to find the coefficient of the term that has BU6. So if I do this expansion, you can grab the Pascal's triangle, go to row number 7, do the expansion, and then find which term has a BU6. But there is a way quicker way of doing this. So if you have a BU6, this one is telling me the term number, no? Like, so this one is telling me exactly what is the value of r. Because, so if you have noticed in the term, it is always like, in the general term, so this is r minus n, and this one is r. They always add up to the number of the row. So what I am telling you is that this number, the one in the second term, tells you what is the value of r. So this one, okay, so you know that this is row number 7 and that the value of r is 6. So what I am telling you is that you can use the general term formula. If you look at this can tell you what is the value of r, and this will tell you what is the value of n. So this is telling you need to find the term that has an r6, n7, and you know what is a and what is b. So if I give you this question, it's the same as the last question. No, it's the same as this one. In this one, I am asking you for the fifth term and to apply the formula. And you did, 5 minus 1, 4, and that is how you found r. In this question, I am already telling you what is r, and I am asking you to apply the formula. So, like, you know now that, a is 2b, b is u, n is 7, and r is given here by this little 6, because u is the second term, and u is the one that holds, the second term is the one that holds the value of r. So again, I just apply these numbers in the formula, and that is like, okay, 7, choose 5, no, 7, Mr. Cacho, here's a mistake. It should say 7, choose 6. And look, this one says 7, choose 6. Oh, Mr. Cacho. Mr. Kachowski, this is 7 choose 6, o sea, 7 factorial over 6 factorial times 7 minus 6 factorial. You put this into your calculator, or if you do it mentally, this is 7, no? So 7 times 2, because this is 2b to the power of 1, that is 2b, 14bu6. So, well, the coefficient is just 14, but this is a term that corresponds to this combination of variables. Okay, let us do another one like this. Again with the with the general term formula. So what is the value of r? Which one tells me what is the value of r? Is it u or is it b? Is the value of r2 or is the value of r4? If you said that the value of r is 4, then you are damn right. Why? Because 4 is the exponent of the second term. So here I know that r is 4 because the second term has an exponent of 4. And you may be asking now, okay, Mr. Cachoa, how do you find n? Oh, n is the power, no? It's the exponent of outside of the binomial. So I just need to use the formula again. So that is 6 choose 4. The first one to the power of 6 minus r, o sea, 2. And the second one to the power of r, u squared is u, negative b to the power of 4, that is just b to the power of 4. 6 choose 4, it is 6 factorial over 4 factorial times 6 minus 4 factorial. Put it into your calc, that is 15. So the answer in this one would be 15. No, that it would be the coefficient of the term u squared b4. Okay, so what have you learned in this last couple of exercises? That the second term tells you the value of r. But what if I am being a horrible monster and now I am not giving you the second term? I am telling you that I want to know the coefficient of the term y squared. So I don't know if you have noticed, but these two terms, 2 plus 4, add up to 6. Or for example, in this previous one, b to the 1, u to the 6, 1 plus 6, add up to 7. So if I am not giving you the second term, the exponent of the second term, you can use the exponent of the first term to find it. So if I know that this is y squared, I know that the value of r is going to be 5 minus 2, 3. Oof, I should have written this down. Sorry. Alert, alert. I did not write this down. Write it down. Think about it. I should write it down. I cannot do it. So if I am not giving you the exponent of the second term, you can use the exponent of the first term of the y to find it. You do the power n minus the exponent of the first term. So it is 5 minus 2, 3. That is how you find the r. And now that you have the r, well, now you can just apply the formula. Y is a, 3 is b, n is 5, and r is 3. Oof! Well, you apply it. We have done this many, many times. So this is 5, choose 3, y to the 5 minus 3, o sea, 5 squared. I wrote this in here because I want to make an emphasis that is how you find the r, no? 5 minus 3. The 2 is because that is a 5 minus the r. Okay. Damn! Is it r? What is 3 cubed? 3 cubed, that is 27. It's not 9. Oof. Mistakos. I am so sorry. This is, oh my gosh. This is 3 to the 3, that this should be 27. So this should be 270 y squared. Ah, Mr. Kachoa, sorry. Okay, now let us go for the tough cookies of the review packet. The tough cookies of the review packet, I chosen 5 exercises from the more practice set. And if we go to the more practice, I want to do them in this order: 2, 1, 3, 5, and 8. So 1, 2, 3, the first 3 questions are very similar. We're gonna do basically the same thing in this first 3 questions. I believe that the second one is the easiest one, so I'm gonna do the easiest one. Then these two are a little bit hard. I strongly believe that question number 5 of more practice is the toughest problem in the review packet, and then number 8 will be easier than number 5. No, no es cierto. Number 3 is the hardest problem in the review packet. And this, okay, so recap. These 3 are very similar. 2, 1, 3 are very similar. This is the easiest one from the 3. This is the hardest one from the 3. The spirit of these 3 questions is the same. Questions 5 and 8 are, they do have the same spirit and are very important. I hope that you can see the spirit. Okay, so let us begin with question 2. So in question 2, I am telling you that the third term of this expansion is this, and I want you to find the value of p. So I am telling you that the third term of this expansion is this. So the spirit is that I want you to find the third term and make it equal to this that I have given you. That will give you an equation that will make you capable of finding p. How do you find the third term of this expansion? Well, again, you could use the Pascal's triangle. You could use the general term formula. If we're going to use the general term formula, because I want to find the third term, that means that r is 3 minus 1, 2, that my exponent is 8, a is x, b is p. So by using the general term formula, 8 choose 2, x to the power of n minus r times p to the power of r. So that is 8 factorial over 2 factorial times 8 minus 2 factorial times x to the power of 6 times p to the squared. No? Okay, and if you put this into your calculator, this is a 28 x to the power of 6 p squared. So right now, I've just did what we have been doing before. No, I just grab the formula and find out the third term. If you are enemies of the general term formula, you can do this with the Pascal's triangle. But I don't suggest you to do it because there may be a problem where you cannot use the Pascal's triangle. Imagine that I give you an exponent of 256. If I give you an exponent of 256, that means that you will need to draw the Pascal's triangle up to row 256. So I don't know. Uh, so now that I know that this is the third term, I want this third term equal to this term that I gave you, no? So I have 28 x to the power of 6 p squared, no, the term that I got using the formula, equals to the given term 252 x to the power of 6. So what can I do to solve for p? I want to solve for p. So I can cancel out the x to the power of 6. So because I have x to the power of 6 on both sides. Then I can divide by 28, chumpao, and then, well, if I do the division, that is 9. So p squared equals to 9. That means that p equals to plus minus 3. So what did we do in this problem? So in this problem, I found the third term, using the formula, that is this, I once that I have found that third term, I make it equal to the given term, and then I solve for p in that equation. In the first problem, I am telling you that x to the power of 5, the coefficient of x to the power of 5 is 56. So, with this information, I know that 56 x fifth is a term in this expansion. So 56 x fifth is a term in this expansion. And well, which term? How can I find a term using the formula? So if I want to apply the formula to know which term corresponds to this one, so look, again, I am a monster. Instead of giving you the exponent of the second term, I am giving you the exponent of the first term. So the value of r is 8 minus 5, 3. I am so sorry. Here I was intending to write down 8 minus 5 equals to 3. Okay? If I had editing powers, no, if I was like an editing monster, I would be able to solve this. No, but it should say 8 minus 5 equals to 3. Because I am giving you the exponent of the first term, I can find the value of r. The spirit of this question is the same as the last one. I am giving you a term. I am finding that term with the general term formula. I will set up an equation, and with that equation, I will find the value of a. So, using the general term formula, 8 choose 2, that means that x to the power of 8 minus 3 times 2 to the power of a. So my term is, like 8 factorial, 2 factorial, a minus 2 factorial. I put this in the calculator. 2a to the power of 3, that is 2a cubed, o sea, 8a cubed, no? Then 28 times 8, that is 224, x fifth, a cubed. In this problem, I have what is going on. I am telling you that this term corresponds to this term. This one, I just find it by multiplying the 56 times x to the 5. Then I found this term by applying the general term formula. And now I'm going to make them equal. This is going to be equal to this. 56x to the power of 5 is the same as 224 x to the power of 5a cubed. Again, what can I do? I can get rid of the x to the power of 5. I divide by 224, and I take the cube root. So this is my answer. Job. I know. It's actually a half. This is if you put this into your calculator, 0.5. So it's not a horrible number. But yes, this is how you do it. It's the same spirit. So like you put the term that I gave you, you find it with the general term formula, you make them equal, you find the value, you cancel the x's, you find the value of a. Now, this problem, kids, this problem, I believe that it's the hardest one in the whole guide. That doesn't mean that it's not important. That doesn't mean that the next two are not important. If you want to skip this one and go to the other two, and this one do it at the end, okay, like for this one, I need you to be like very patient. I'm gonna make a big effort to explain it properly. If you're scared, you can like hold your pet, hug a friend, I don't know, call a friend. Okay. This is problem number 3. It says in px squared times 5 plus px to the power of 8, the coefficient of the term x6 is 3402, and I need to find p. So I am telling you that the coefficient of the term x to the power of 6 is 3402. As in the last problem, that means that this is a term of this, no? O sea, multiplying 3402 times x to the power of 6 is a term of this thing. Now, if you look, this problem is a little bit different than anything that we have done before. because this one has a px squared outside. So what do we do with this px squared outside? There is a px squared outside. We're scared. So whatever we do uh, with this term, with the 5 plus px to the power of 8, then we're going to multiply it by px squared. So by doing this multiplication, that means that I am increasing the power of x, because like whatever power x will get after this expansion, I'm going to add a 2, uh, because that happens with when you multiply x squared times something, you add x squared, you add the exponents. So this multiplication will increase the degree of every term by 2. So instead of finding the term